Okay, so let's talk through these electron configurations. And I'm actually going to explain something about the ions too. So sodium is element number 11, which means that it has 11 electrons and 11 protons. So this is 1s2, 2s2. That accounts for 4 electrons. 2p6, that accounts for 10. And then the next thing is 3s, and there's only 1. Now let's say this was an ion. Right now, the highest occupied energy level, well, all of the energy levels, we've got 1 energy level here with 2 electrons, second energy level here with 8 electrons, and then the third energy level, we have only 1 electron. So if this were an ion, we would say, hey, look, you can either gain 7 electrons or just get rid of that 1, and that would be Na plus 1. Iron, let's find iron on our handy dandy periodic table. Iron is Fe, it has 26 electrons. So we're going to write that in there. We're going to go ahead and say there's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. I think it was 6. Let's check and make sure. It was 1, 2, 3, 4, 5, 6. Yep. 3d 6. Now, let's look at the energy levels here. So energy levels that are occupied are 1 with 1 electron, or 2 electrons, 2 with 8, 3 with 8 plus 6 is 14. But in the fourth energy level, there are 2 electrons. So if we were looking at this one, we'd say, okay, get rid of those 2, and Fe becomes a plus 2. Bromine is over here. Whoa, losing track of my periodic table. Br is element number 35. 35. So let's go back to our handy dandy sheet over here. And that would mean it has 35 protons and 35 electrons. So let's go ahead and fill in. We got 35. So we're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. That counts for, let's see, 2, 4, 10, 12, 18, 20, 30, and we said it was element number 35. That means we got 5 more to account for, so this is 4p5. Now, in the fourth energy level, look at this here, fourth energy level, which is the highest energy level, we got 2 plus 5 is 7, so this becomes Br minus 1. In other words, we just want to add 1 electron to make that 8. All right, barium. Let's figure out where our old friend barium is. Ba is element number 56. All right, I know it says unabbreviated, but I'm going to abbreviate it. So I'm going to look barium. I know everything up until it's in this row here. So I'm going to go up and over. I know everything up until Xe is completely filled. That accounts for 54 of the electrons. And now I've just got these 2 to account for next. So I'm going to go ahead and say Xe in brackets. And then it's in, let's figure out which energy level it's in. It's in number 1, 2, 3, 4, 5, 6. So this would be 6s2. All right, magnesium is element number 12. So we got 12 electrons to account for. I'm going to do this the long way again. So I know that it's in the third energy level. So this would be 3s2. And I'm going to work my way backwards. 2p6, 2s2, 1s2. Highest occupied energy level, well, here's 1, that's got 2, here's 2, that's got 8, and here's 3, that's got 2. So the highest is 3 energy level, third energy level. There's 2 electrons. We could either add 6 or take away 2. We're going to add, we won't add 6. So we just get rid of that one. This would become Mg plus 2. All right, so 3p4 is what I want to pay attention to here. So let's take a look at what 3p4 is. 3p4 is third energy level, 1, 2, 3, 4, it's sulfur. So I just write S in that box. All right, next one is 5s1. So let's go to the fifth energy level, 1, 2, 3, 4, 5. S1 is the first one, so it's rubidium, Rb. Way easier to do it this way, right? Rubidium is right there, okay, and then 4p6 is going to be a noble gas because it has 8 electrons, outermost energy level. So 4p6. So we're going to go 1, 2, 3, 4. It's Krypton. Superman's home world, it's Krypton. Okay, and then this one's 7s2. So I'm going to go 3 energy levels. 1, so I'll go 1, 2, 3, 4, 5, 6, 7, S1, S2, Ra, radium. Ra. Okay, this next part says, determine which of the following electron configurations are not valid, and then state why they're not. So we're going, let's make sure. We've got 1s2, that seems reasonable, 2s2, 2p6, 3s2, 3p6, 4s2, 4d10. No. That's the problem here. 4d10 would not come next. It would be 3d10 in that place. And then 4p5. Okay, let's take a look at the next one. 1s2, 2s2, 2p6, 3s3. Uh-oh. So we can't have 3 inside of that one, so it would have to be 3s2, and then D can't come after the 3s, so this would be 3p6. So we got 2 mistakes in that one. Okay, and then this last one, we got the electron configuration inner and valence electrons. Okay, so let's do this. Let's bring in we definitely need this periodic table to be a lot closer to us and more accessible. So boron is 2p1. So over here, we'd write in here, this is 1s2, 2s2, 2p1, or He 2s2, 2p1. Inner electrons, there's these here, so there are 2 of those. And outer electrons are in the highest energy level, which is the second energy level. There are 3 of those. Okay, silicon is 3p2. So we're going to work our way, I'm going to work my way backwards just because it'll be easier. 3p2, and before that is 3s2. Before that is 2p6, and before that is 2s2, and before that is 1s2. Or I could get rid of all that and go Ne, 3s2, 3p2. Inner electrons would be everything up to neon, so that's 10. And then 3s2, 3p2 is 4 valence electrons. Sulfur is 2p4, or 3p4, sorry. So it's going to be exactly the same as the last one. Which makes sense because they're in the same row. 2s2, 2p6, 3s2, 3p4, or Ne, 3s2, 3p4. This has 10 and 6. calcium is element 20, and that is in 4s2, so we'd work our way backwards. 4s2, 3p6, 3s2, 2p6, 2s2, 1s2, or AR, 4s2, and AR has 18, and this has 2. Iodine, let's look at where iodine number 53. Okay, I'm just writing out the abbreviated. That's too long. So iodine is 53. So we go up, it's Kr. Everything up to Kr is filled. And then we're going to go straight across. So we're going to go, this is 1, 2, 3, 4, 5. 5s2, 4d10, 5p5. Let's go ahead and fill that in. I said it was 5s2, 4d10, 5p5, which means it has, whatever krypton has, 36 electrons. 36, and then if we add these up, 2 plus 5 is 7 valence electrons, and actually we got to add this fourth energy level, so this actually ends up being 46. I forgot that those are of lower energy because these are 4D and these are 5 and 5. Okay, 2 more left. Rubidium and chromium. I'm just going to give you those. Rb is rubidium's element number 37. So that means that I can count on it. It's right over here. So that means that it has whatever krypton has, which is 36 electrons and just 1 valence. So I'm just going to fill that in. 36 and 1 valence. And the last one is chromium, Cr, and that is 24. So that means that it has 18. Actually, let's write this one out. Cr is 3D, let's see, 1, 2, 3, 4. 3D4 is where it's ending. 3D4. All right, so we're going to go 3D4, means 4s2 is before it, and the noble gas that's before that is AR. AR accounts for 18, but we've got another 4 that are from that 3D, which means that the number of valence electrons is 2. I'm just going to, just for a bonus, I'm just going to go back. If this has 3 valence electrons, that means that it would either be a +3 or a -5. It'd have to gain 5 electrons or lose 3. This could be +4 or -4. This could be +6 or -2, +2 or -6, +7 or -1, +1 or -7, and then +2 or -6. So whatever number's lowest wins on this guy here. So you're going to lose 3 electrons and become a +3 here. This one, it depends. It doesn't really follow these rules. This one is going to become a -2 by gaining 2 electrons. This one is going to lose those 2 electrons that are here. This one is going to gain 1 to become 8. This one is going to lose that 1 to become a +1. And this one here, you can probably guess, is going to lose 2 to become a +2. Hope that makes sense. See you tomorrow.